Hello, this is Robert Rickover at Body Learning, and today my guest is Tim Cacciatore, who is an Alexander Technique teacher who lives in London, England. Prior to that, or in addition to that, has a PhD in neuroscience from the University of California, and he also has a postdoctoral fellowship had a postdoctoral fellowship with the Oregon Health and Science University in Portland, Oregon, and now he has moved to London and is a senior research associate at University College London Institute of Neurology. Tim has written two papers that have been published in academic journals concerning postural tone and some of the implications of that in terms of how people who have studied the Alexander technique have different quality of postural tone and are able to perform a simple movement, in this case getting out of a chair. And we're going to talk to Tim today about those studies and about the implications of them. Tim, welcome to the show.
Hi, Robert. Thanks for having me.
Tim, could you begin by giving our listeners a very short description of the Alexander technique?
Sure. I would describe it as it's a way to regulate patterns of muscular tension that allows you to achieve an elongated relationship in the head, neck, and back that has numerous benefits. Benefits in how you move, in how you breathe, in your quality of attention, and for your health.
Mm-hmm. And I think it's worth noting that there have been a number of medical and scientific studies about the effectiveness of the technique in various areas: breathing, Parkinson's disease, aging, and perhaps most dramatically back pain. Fairly recent, a large-scale study conducted in the UK sponsored by the National Health Service there that pretty conclusively showed that the Alexander technique was an extremely effective way to alleviate back pain. And now your work, it seems to me, and I'd like you to elaborate on this a bit, tends to be more about the mechanisms that might underlie those effects that have been noted in other studies. Would that be a fair assumption?
I would say that's definitely part of it, but it's also broader than just the effects of that are observed in other studies. So, when you have a series of Alexander lessons, there are also a number of observations that you observe, that things that happen, and it's also trying to understand what those are scientifically.
Mm-hmm. So could you summarize the two studies that have been published, and we'll put links to a way to find those by the interview, and I believe you're working on three more, which I guess you can't really talk about too much right now. But the two that you have done, one of them is called Increased Dynamic Regulation of Postural Tone through Alexander Technique Training, and the other Prolonged Weight Shift and Altered Spinal Coordination during Sit to Stand in Practitioners of the Alexander Technique. So they sound pretty technical. I wonder if you could distill the essence of those for our listeners.
Sure. Well, I'll give it a shot. I guess let me just start out by saying, from a broad brushstroke, that there's basically three elements to motor behavior, and in a way, these studies deal with all three. The three elements are movement. So when you generate a movement, you accelerate your body from point A to point B. I think we all understand that. The second is balance, the task of balancing, which is keeping your center of mass of the body above the basic support, which is typically your feet. Or if you're on all fours, your mass has to be above your arms and your legs. And the third aspect of motor behavior is posture or postural tone, which is really about anti-gravity support and counteracting gravitational forces. And this, in a way, is what the first study deals with. Now, oddly enough, you'd think that supporting yourself against gravity, that would be very well understood scientifically, but it turns out it's not, and there are technical reasons for that. It's generally hard to measure this activity, and so it's hard to study. When I started my postdoc in Portland, I had the fortune of working with a man named Victor Gerfinkel, who had spent a long time thinking about how you measure this anti-gravity support. Basically the tension, the patterns of tension or muscle tone that hold us up against gravity. And he sort of devised a way to do this, and the device is called Twister. And essentially, the way it works is it's fairly simple. It basically rotates, one part of the body relative to another. So imagine, for those who have had Alexander lessons, often a teacher might put their hands on your head and rotate it very gently from side to side. And the more resistance that the teacher feels, it has to do with the more activity going on within the neck to support the head. And let me just add that there needs to be that anti-gravity support, because without any sort of muscle activity counteracting those gravitational forces, the skeleton collapses. And we've all had evidence of this. If you're sitting on a train or something and you're tired, you fall asleep, your head will drop forward, because without that support, the structure collapses, basically.
Right. So, a typical Alexander technique take on that is your neck muscles need to do something, but it's not good if they're doing too much, or if they're stiff, let's say.
Yes.
Right.
That would definitely be the sort of Alexander perspective. So with this device, before we get into the study and the technique, just briefly, the one thing that's special about it is it twists one part of the body relative to another without providing postural support. So you can't lean on the device; otherwise, you could relax into it. If that makes
right.
But before we put Alexander teachers in it, we looked at just normal subjects, and what we found is that people have a huge range of how stiff they are. Several fold, 3 to 4 times. A stiff person is 3 to 4 times more stiff than someone who's not stiff. That's a phenomenal difference. If you think of the difference in height, imagine if a short person or a tall person was 3 or 4 times taller than a short person. There'd be a much greater variation in height. So there's this huge difference in stiffness.
Right. And then when you studied Alexander teachers or Alexander students, the range narrowed quite a bit, as I recall.
Well, it went down. So with teachers, they have on average about half the stiffness within the neck, the trunk, and the hips, with kind of the central part of the body than your average person.
Mm-hmm.
That's a lot. That's a big difference.
Mm-hmm.
That's a big difference.
And would the implication of that be that since they are managing to stand up with less muscle tension, that's probably a sign of more optimal use of themselves?
I wish it was that easy, but it's not. It's not clear. It may be that way, but there are with muscle tension, right? There are two reasons why someone could be not very stiff. One is they could have not a whole lot of postural support going on,
Mm-hmm.
less muscle tension overall. But the other, for technical reasons, our twisting is very slow, and so the nervous system has a chance to adapt and change this muscle activity. And if it changes, that affects the stiffness.
Mm-hmm.
So, for instance, if muscles that were stretched with the twisting, they reduce their activity and let go, so they were allowing the twisting to take place rather than resisting it. This would basically cause a low stiffness, and it's just difficult to differentiate what actually happened, whether it's more dynamic low stiffness is due to changing muscle activity or due to just less postural support.
Mm-hmm. So where does that study then, looking at it by itself, where does that leave you in terms of the implications about the usefulness of Alexander teaching? That you can see a definite effect, but it sounds like you're not 100% sure whether that effect is a useful one or not. Would that be a fair summary, or is that overstating it in the other direction?
Oh, I think it's overstating that in the other direction. No,
Okay.
I think it's the implications of it are not completely clear.
Mm-hmm.
I mean, first of all, there is one more piece of information with this study is that we through a variety of reasons, a variety of methods, we were able to conclude that the decrease in stiffness, at least in Alexander teachers, is due to more adaptable activity. This kind of more flexible, responsive muscle tone.
Mm-hmm.
And that's interesting in and of itself because muscle tone it's a fundamental aspect of human motor activity. It's there all the time, and if you're changing this fundamental thing, that's that could easily have implication in loads of aspects of behavior.
Mm-hmm.
And so it's clear that it's changing something fundamental in an interesting way.
Mm-hmm.
We don't understand all the implications of that, or exactly even how what brain processes are responsible for that change.
And I believe that the effects, we'll say, taking the control group versus Alexander, people who are Alexander teachers, these are people who've gone through a pretty intensive training course and have devoted a lot of time and energy to studying the work, was more pronounced than, say, the control group versus students, some students who'd had a number of lessons in the technique. But they too, as I understand it, showed a change in the same direction.
That's right. Yes, that's right. So if you remember the decrease, the difference between teachers and control, so after this 3-year training, was a 50% difference.
Mm-hmm.
And the difference between students after a course of 20 lessons was a 30%, roughly a 30% decrease.
But that's still quite significant.
It's substantial, yeah.
Yeah.
It's substantial. That's right. That's right.
So
Yeah.
then the second study
Yeah.
that you did, it seems to me what you've done is taken. You said, well, let's look at a specific activity that people do as they go through life, which is standing up from a sitting position, and
Yeah.
analyzed the difference between how a control group does that and how people who've been trained in the Alexander technique do that. And could you summarize what you found in that study?
Sure. Sure. I mean, first of all, the standing up movement, we chose that sort of for reasons that are obvious to people who've had a lot of Alexander, in that it's a common procedure that's used in Alexander, and there are it's used as an evaluation and a teaching tool, and it seems a good way to try to get a handle on what sort of changes were happening within movement. And basically, what we found, we looked at some very basic things. We looked at the phasing. So there's three parts to standing up. There's moving your mass forward, so leaning forward, and then there's shifting your weight onto your feet, and that serves to basically counteract gravity when you lift up, and then there's elevating the body. And we looked at the durations of those. We also looked at how smooth the transition was onto the feet, and we also looked at the coordination within the back during this activity. And what we found was that Alexander teachers coordinate the movement in a very, very different way. There's been hundreds, at least over 100, of studies on the sit-to-stand movement, and basically the way that people typically coordinate this activity is they do it in two actions. They bring their body forward, and then they rapidly shift their weight onto their feet and raise the body up. So there's kind of a coming forward. That's the first phase, and then they abruptly shift their weight and elevate the body. And we found that teachers basically coordinate these together. So the second they start leaning forward, they start shifting weight onto the feet, so that the weight actually shifts over a much longer percentage of time. It's a much smoother action.
And probably, I would think, a more efficient action, just looking at it from an efficiency point of view.
Most likely, yeah. It most likely is. Typically, in controls, for instance, you see before they weight the feet, they actually take weight off the feet. And they do that to accelerate. It accelerates the trunk forward. It gives you more momentum, and so you're generating more momentum, and then you have to break that momentum to stop you going forward and move upward. And so yes, it probably is a more efficient action. We don't know that you actually have to measure energy in things like watts or oxygen consumption or whatever for sure, but there's a lot of indications that suggest that would be the case.
And it's interesting because I'm sure you're familiar with the studies done by Frank Pierce Jones back in the, who knows, 60s maybe. He was a professor at Tufts University who, also an Alexander technique teacher, who used strobe photography to observe the pattern of movement of students as they stood up from a chair or sat down in a chair. Now, I think his work involved a teacher actually guiding the student as they were doing it. But the general take on it is that the movement was smoother.
Hmm. Yeah.
I think that's a fair summary of it. And it sounds like you've kind of looked at it from the point of view of actually measuring forces and so on, which he did not do.
Yeah, yeah. I mean, what Jones found, I think his studies are amazing, actually, given his background and given the time, and the tools that he had. I mean, it's a completely different world nowadays,
Hmm.
doing these sorts of studies, and I have all the time in the world for his research. But what basically if you boil it down, the things that he found were that that there was this change in the head neck angle in untrained subjects without guidance that tended to change with guidance. There was also lower velocity and lower accelerations that were used to achieve the movement in the same time.
Hmm.
And those are kind of interesting because it's a bit paradoxical. How do you have lower accelerations and achieve the movement in the same time? It's interesting.
Hmm.
But I think what that study lacked, and again, it was no fault of Jones. It just, I don't think it was possible at that time. It was the first study ever on the sit to stand movement. It really was. But the relevance. So what is the relevance of the changes in the head posture?
Hmm.
What is the relevance of the lower acceleration?
Hmm.
Uh, um, and yeah.
Well, it sounds also, I mean, maybe another way of looking at it would be that we talked about efficiency of movement, and as you said, that would be very tricky to measure directly. You'd have to measure caloric activity, I suppose,
Yeah.
or something like that. But if you think of going from sitting to standing, um, it sounds like the in your study, and I imagine also in Frank Pierce Jones's study, that
Mm.
the people who had Alexander training, or in his case Alexander help, I guess, made that movement in a more direct way. That is, you described the beginning of standing up for the control group was kind of a lessening of pressure on the ground, and then to get a faster acceleration forward, and then they had to kind of suddenly change gears, and the actual movement of the body from its original location to its new location is just less clean, less direct. Would that be a way of looking at it?
Yeah, yeah. I think I can probably summarize that it fairly concisely. The reason why the teachers had this, you could say, more direct movement without these additional, unweighting the feet and accelerating the body forward, is because they were able to solve two different problems simultaneously. They were able to come forward with their body to solve the balance problem, to get their mass over their feet. At the same time, they're able to weight their feet. And by being able to solve these tasks simultaneously turns out to be fairly difficult, actually. It's hard for an untrained person to generate this smooth activity because it winds up requiring that you have what's called lengthening or eccentric contractions in the legs, which means that muscles that are generating the activity to shift weight to the feet have to actually be lengthening.
Mm-hmm.
And that may sound paradoxical because how does a muscle lengthen when it's generating force? And the answer is actually fairly simple, is that it needs to be pulled on both ends. You need to be stretched
Mm-hmm.
by forces or energy from elsewhere in the body.
Mm-hmm.
And so what we think is that that teachers are able to drive these lengthening contractions more easily, either because they're less stiff in their legs, which is consistent with the measurements of muscle tone that we talked about earlier, or they're able to conduct the energy from momentum or from gravity from the upper body, largely, to the legs to drive those lengthening contractions. And the other thing that we found in this study was that the back of Alexander teachers stays fairly straight during this movement. Where in control, there's a lot of spinal movement in various ways, and this has been documented by others before. And it turns out that having reducing that movement within the spine winds up actually transferring mechanical energy through the spine to the legs in a way that would act to stretch the hip and the knee muscles so that they continue to lengthen, and you keep the body moving forward while you are generating force with those muscles to weight the feet.
Mm-hmm. Well, it is interesting that just from an Alexander technique teacher point of view, most teachers could identify with this, that often when they help a student, show a student a different way of getting out of the chair, which, as you say, is a pretty standard teaching procedure, the student will often say something like, "Oh, that feels so much lighter than I'm used to," or I almost don't know how I got to standing.
Exactly.
Because I didn't, and you know, a teacher will say, "Well, you didn't create your usual habitual tensions that you previously used to stand up that were not actually all that necessary. You moved in a more efficient, albeit unfamiliar way," and that's certainly, I mean, your sort of scientific explanation or mechanics explanation fits in with that perfectly.
Yeah,
So,
absolutely. I think it.
so I know that you have three more. I think you mentioned earlier before we began the interview, three more studies in the works, and you can't really talk about them. I would imagine, I don't want to predict what they're going to be, but I would certainly imagine, given that standing up from a chair is a kind of an Alexander teaching procedure, that what would be interesting would be to study some other kind of movement that is also an ordinary, everyday one that is not necessarily emphasized all that much in Alexander lessons directly. That would certainly be a nice study by someone, possibly you down the road.
Absolutely. I think that's definitely an interesting question, because we're measuring an action that is very well practiced by Alexander teachers, and so it doesn't really address the question of how general.
Right. But it's heading in the direction of looking at how these postural tone changes that come out of your first paper might have implications to real world activities.
Exactly.
I mean, that's the direction of that second paper for sure.
That's right. Yeah.
I think we're probably pretty much at the end of our time. Is there anything that we haven't mentioned that you think would be important to say before we come to an end?
No, I think that pretty much covers it in terms of those two studies. Yeah.
Okay. Well, my guest today has been Tim Cacciatore, who is a trained as an Alexander Technique teacher. He's also a PhD in neuroscience and currently a senior research associate at University College in London. We will put links to the two studies that have been done so far, and also a link to an article in an Alexander journal, which gives has a nice picture of that device that you used in Portland, and talks a little about the first study, and we're going to look forward to more studies in this same vein down the road. Tim, thank you so much for being on the show today.
Thank you for having me.